students. So in unit 1, so we have seen so the stress equations for the machine components by the application of different load. So for example, it is subjected to the actual loading condition, that is a tensile load. So the stress induced is the load by area. It is subjected to the bending moment. The bending stress is given by M by Z. So similarly for the torsional moment, the torsional shear stress is given by dt. So in these cases, so whatever the equations we have written for the calculating of stresses, so there is an assumption that so the cross section of the cross sectional area of the machine component is uniform. So these basic relations which are relates to the we are assumed within the component having the uniform cross sectional area. But in coming to the practical cases, so these equations are not applicable. So that is not use the best results and the same stresses does not yields because of the uniform cross section area is impossible to maintain uniform throughout the cross section. Okay, so these are the equations we have written. So based upon that, the uniform cross section is uniform. But in the practical cases, in actual cases, it is impossible to maintain the uniform cross section area throughout the width or throughout the length. Why? Because so if you need to change or if you need to provide any hole in the machine component, because it is a requirement of the machine component to assemble with another machine component so that in order to join the two machine components you can provide holes, or there is a chance to provide drill some holes or oil holes you can provide for lubrication purpose. So likewise there is a many of the causes. If for example you can you need to place hub on a shaft, so we can make keyways so that you can provide a key in that. So likewise there is many of the geometrical differences will be there. So geometrical features need to be included in the machine component rather than providing a uniform cross sectional area. Clear? So in that case, so the stress, so where you can observe the stress near these geometrical abstracts, so the stress may be a greater compared to the calculated stress using the normal equations. Clear? So that is what we are going to discuss in this unit. So that is a stress concentration. Clear? So as you can study in your previous course, fluid mechanics. So in that, so the fluid lines can pass through the pipe in a lines. So in a similar fashion, so in machine components, the stress lines can also flow like lines within the object. So here, as I stated, so if the component is uniform, the stress lines can flow smoothly from one direction to the another, so that the stress induced at each and every section you can consider the stress induced is the same. But whenever it is required, so which means whenever if you change the geometric construction, regardless of the uniform area, the stress induced near the that is vicinity of the hole, we can observe the stress induced is maximum. So here if you observe, so this is if you can provide a shoulder here, so that is a stapled shaft you can take. So these stress lines can tend to bend. So there is a chance, there is a sharp bending of the lines from larger diameter to the smaller diameter. So due to these bending of sharp bending of the lines causes a stress concentration. So that is a stress induced near these particular places, which is greater compared to the stress that you are going to calculate using the normal equations. So that what we call it as stress concentration. So similarly you can observe here, so this is a rectangular plate. If there is no hole in this rectangular plate, so that the stress lines can flow smoothly in this fashion. But here, so you can drill a hole in the rectangular plate. So here the stress induced is sigma d, that is a P by A, so at this section. But whenever you can consider at this particular section, the stress induced is very much high. So here stress induced is very much high in this fashion. So at near the pole, so whenever there is a geometric obstructions here, so that is a sudden changes in the geometry that will produce us a greater stress. Clear? So here can denoted defined as it is a localization of high stresses due to the sudden changes or abrupt changes, that is sudden changes in the component or due to irregularities. So this stress concentration can also cause us, so not only because of the geometrical features we are going to include in the machine component, so there is a causes which can also produce a stress concentration, like if it is a possibility of cracks on the surface, that will produce a stress concentration. If it is in defects, crack-like defects upon the surface, like slag inclusion or something else, etc., it can cause us a stress concentration, or due to surface roughness causes a stress concentration. So there is many of the causes that may includes. So majorly this can be defined as the localization of high stresses due to irregularities or any sudden changes in the cross section, which will produce us a high stress concentration. That is a high stress will be induced, that we call it as stress concentrated at these particular areas. So due to these flow of lines is going to disturb within included geometries in the machine component. Clear? That is what stress concentration is. So now let us see what are the various causes. So as I stated, so here not only the sudden changes in the cross section due to the inclusions of slag or cracks or surface roughness values, all these comes under the causes of stress concentration. Let us see what are the stresses of stress concentration. So here, so the first one, that is a variation in properties. So for example, so it can take a build wheel. So you can observe clearly. So there is a difference in properties can be observed between the two machine components that will cause us a very great stress concentration at these particular areas. So as well as this is the inclusions in the cast product. So you can in a microscopic view you can observe it as there is a foreign material. We say that the foreign material that can be included in the machine component or in the material during the casting process. So due to these inclusions of foreign materials, it causes a stress concentration as well as so here you can observe this is also a weld joint. So that is due to the property changes, variation in the properties. So that will give rise to the increase in stress at those particular areas due to that inclusions. So that this is one of the cause for stress concentration. One is a variation in properties. So whenever there is a change in property due to a welding process or due to some crack, that is inclusions that present in the material, or here you can observe the crack. So due to the crack produced in the component. So cracks you can observe don't observe with the naked eyes, but in the microscopic you can observe various cracks can be observed on the surface of the machine component. So due to that you can induce us a greater stress, that we call it as a stress concentration, that is concentrated at one single point, at one particular cross-sectional area or one particular point of application of load. So observes the stress concentration. So that is the first one, variation in properties, and second one, load application. Due to the load application, so if it is a load is not distributed over the throughout the component, but instead the load is acting one particular point, so that we can also use rise to the increase in stress. So here you can observe this is a rail track. So whenever the wheel can move upon the track, so there is only a point contact will be there between the wheel and the track, so that total load can be taken place at one single point. So that the track will be subject to the stress concentration where the load is acting. So similarly here in the ball bearings, so there is only a point contact between the balls and these races. So at the inner race as well as the outer race, so which causes stress concentration. Again a point loads only the load is concentrated at a single junction. So similarly for gears, so whenever the teeth will meshes, so there will always a point contact. The total load can be transferred from one gear to the another by the meshing of teeth of a single point. So you can study that in a law of gearing, so that this can also gives rise to the increasing stress. So due to the load application, the type of load applications you can apply on the machine component that gives rise to the maximum stress, that we call it as stress concentration. Clear? So that is a second cause. So that is load application. So based upon the type of load we are going to apply on the machine component, the stress induces in the machine component is going to increase. That is, the stress is going to concentrate at one particular part. And second one is the sudden changes in the dimension. So here, in order to place hub upon a shaft, you can reduce the diameter. So here you can observe it is a larger diameter shaft, and here it is a smaller diameter. Whenever there is a sudden change in the cross-sectional area, so which causes a stress concentration at this particular reduction in area. Whenever the area is get reduced, so the stress line is going to converge through this channel from larger diameter to smaller diameter, gives rise to the decrease in stress, and that can be particularly concentrated at this particular junction. Clear? So this is also one of the cause for stress concentration. There is a sudden changes. Not only this, this is an example. If you can place a hole here, so you can drill a hole, or you can make kept in oil holes, or if you want to create some sudden changes in the cross-sectional areas. So by placing a quarter here or rectangular slots, or whatever you can prepare, there is any change in the cross-sectional area, and it is a sudden change with the cross-sectional area, that will give rise to the stress increases. And fourth one, discontinuities in the component. So here if you observe, so there is an oil holes can be drilled in the machine component. So as stated earlier, so whenever the holes are provided, there is a discontinuity. So here one more example, that is a keyway. So you can provide a keyway here in order to maintain to avoid a relative motion between that two machine components. You can provide a keyway, internal keyway or external keyway. So there is a chance of induces a stress, that is a greater stress compared to the normal stress. Clear? So this is the one more cause for the stress concentration. So either variation in properties, that is variation in the sense that maybe on cracks, on surface cracks or surface roughness, or foreign metal inclusion, or weld bead you can provide, that is a welding operation can take place. So that is one of the cause. So and coming to the second one, there is a that is discontinuities in the component, oil holes or keyways you can provide. And third one, load application, and fourth one, there is a sudden changes in the component. So all will subject to the cause of stress concentration. Clear? But here in the machine component, it is not desired to maintain to observe a particular stress concentrated at some particular areas which will cause to the damage. So whenever the maximum stress induces at some particular areas, so for example you can take a surface defects like cracks. So if the stress is concentrated more at that particular juncture, that is vicinity at the crack tip, so which will causes a propagation of cracks will take place whenever the load is applied on the machine component. So beyond that strength of crack that can withstand, so immediately the machine component is going to fail in a brittle fashion. So that we need to avoid this stress concentration at these particular areas. So, but in practical cases, it is not. It is impossible to maintain a uniform cross section. So it is required to make oil holes. It is required to provide keyways. It is required to change the dimensions in order to provide a hub or some other things. So the cracks, it is not in our hands. It is a manufacturing defect or either casting defect can provide. So it doesn't neglect by the designer. So that if you want to avoid the stress concentration is impossible, but if we are not going to completely avoid the stress concentration in the machine component. It is possible to neglect, or it is impossible to avoid completely the stress concentration, but rather, so we can reduce the intensity of stress concentration by applying some of the methods of adding or removing of the material to the existing geometrical features. So that is methods to reduce stress concentration. We can reduce it but we cannot completely eliminate the stress concentration in machine components. Rather than we can reduce the stress concentration by following some of the following methods. So let us see. So this is also one of the cause for stress concentration, that is the machine scratches or machining marks or indentation you can provide upon the component. It can also raise stress concentration. So this is the methods to reduce stress concentration. So for example, here you can take the additional notches. So this is one of the method in the tension member or in the bending member. So you can use multiple notches. So here drilling additional holes, use of multiple notches or removal of undesired material. So if the material is undesired, so we can remove it, or we can provide notches. So additional notches or additional holes. So for example, you can see here, so there is a one single hole is there, so that these stress lines can change the direction here at this particular juncture. So there is a sudden change in the stress lines that will give rise to the stress, rise in the stress. So that we call it as stress concentration. So if we can allow the stress lines flow smoothly instead of taking the sudden change in direction, that will reduce the stress concentration. So that you can drill the additional holes. So that is one of the method here, drilling additional holes here. So if you can drill the additional hole before and after the required hole, then these stress lines can pass smoothly over these above the observable required hole. So that is the additional holes we are providing. So there is one of the disadvantage. Whenever we can drill the holes, the strength of material is going to reduce by removing the material, but you can provide a small diameter holes which does not matter, so that the stress concentration is going to reduce in the component. That will gives rise to the, that is leads to the increase in the life of the component in order to avoid the failure. Here, so that is the additional notches, or you can provide the notches here. So you can use so notches are undercuts. So here the stress lines can bend in this direction, but here the stress lines can take place a simple change in direction, which is we are allowing the stress lines can flow smoothly by providing the additional notches or undercuts, or by removing the undesired material here. So that is one of the method so we can follow to reduce the stress concentration. That is removing the additional material or additional holes, drilling the additional holes, or providing additional notches. Here are undercuts. And second one, so we can sudden changes in the shaft. So in the stepper shaft, in order to provide the hub, so we can avoid this sudden change in the shaft. So that is a sharp corners we need to avoid it, so that we can provide fillets. So we can provide fillets or undercuts or notches. So here this is the fillet we are going to provide for the component. So that is a smooth corner. Instead of sharp corner, we can provide a smooth corner, so that the stress lines can flow smoothly from one side of the shaft to the other side. So similarly you can provide, so that is a good one, and this is a greater chance of fillet, so that the stress lines even flow smoothly compared to this component to this component, so that the stress concentration is very low in this case. And here we can provide notches here, so double notches here, so that the stress lines can take smooth direction from one side to the another side. So that is one of the method you can follow. So that is again providing, instead of the sharp corners, you can provide with fillets. It is a smooth surface so that the stress lines can flow smoothly from one end to the another end. And coming to the key ways, so we can add fillets for the or we can provide a symmetrical hole. So here you can observe this is the keyway, and here these are the two holes are drilled at the surface. So these are the lines you can observe as a stress concentration in the initial case. So whenever you can drill a holes, the stress can be concentrated in this fashion so that it is going to flow smoothly in a circular fashion. So there is no stress concentrated near these keyway groove. So here, so this is one of the methods drilling additional holes for shaft. So that is a filling notches or symmetrical holes. And for the bolts, so there is a chance of increase in stress concentration here in this fashion. So in order to avoid such condition, so we are having the two methods here. One is undercuts. So this is the undercut portion, that is you can place remove the undesired material at the shank portion. That is the first method. The second method is reduction in shank diameter. That is so we can increase the threads. We can provide the threads above the diameter of the shank so that we can reduce the shank diameter. That is so that the stress lines can flow smoothly in a straight fashion. So instead of taking a curve here. So these are some of the methods. So we can reduce the stress concentration, but we are not going to avoid completely. It is impossible to avoid completely. Rather, we can adapting some of the methods based upon the load conditions. We can either providing the fillets or providing the additional notches or providing the additional holes or reducing in shank diameter or undercuts. So or additional notches. So adopting any of the methods based upon the corresponding to the different load conditions or possibility, so that we can reduce the intensity of the stress induced at these particular junctions. So that is some of the methods we can adopt to reduce stress concentration. And coming to the factors, so the stress concentration factor, that is what we call it as a theoretical stress concentration factor. As I stated, this is the nominal stress which we are going to calculate using the so you can take a rectangular plate with a circular hole. So here, as I stated, where the rectangular circular hole, we are observe the maximum stress, that is sigma max. And this one is nominal stress, we can denote sigma naught. So at the uniform cross section, we can obtain the nominal stress, but where the change in cross sectional area, we can observe the maximum stress values. So for finding out the maximum stress value, we need to take a factor of stress concentration factor. So by knowing the stress concentration factor Kt, so that you can find out the maximum stress. So that maximum stress is given by Kt into the nominal stress sigma naught. So whenever you can know the value of the stress concentration factor, we are able to find the maximum stress induced near the hole or near the crack or near where the stress is going to be concentrated. That is the maximum stress we are going to find. So here this stress concentration factor we call it the theoretical stress concentration factor. It is defined as a ratio of maximum stress near the notch or a fillet to the nominal stress at the same section based upon the net cross section area. Theoretically it is given mathematically, so that it is given by and it is denoted by Kt, depends upon the material and as well as the geometry of the part. So whenever we know the theoretical stress concentration factor, we are able to find the maximum stress induced in the particularly at this junction. So as you can see definition clearly, so you can take a cross sectional area. So at the same cross sectional area, so you can observe the maximum stress as well as the nominal stress. That gives the relation. So it is a ratio of maximum stress at the same section of the nominal stress. So here, so and it is denoted by Kt and it is a theoretical stress concentration factor. So how do we calculate this theoretical stress concentration factor? So whenever we know the Kt value of Kt, so that you can able to know the maximum stress concentrates at particular point. Clear? So in order to find these theoretical stress concentration factor, we are having two different methods. One is a mathematical method and another one is experimental method. So that is KT is given by sigma max by sigma naught or tau max by tau naught. So and these KT can be given in a two different fashions. So one is mathematical method and experimental method. So here in the mathematical method, by using the relation, we can find the value of KT, and in the experimental method by photoelastic technique. So we can use the fringes so that by means of photoelastic experimental setup, by means of photoelasticity technique, by the under the different load conditions, so we can observe the fringes. By means of the fringes, we can observe in the machine component. So we can identify the amount of stress induced in it. So that is case experimental method is. So here the experimental method, which takes a greater time, so we can go with the mathematical method. So corresponding to that, based upon the possibility, you can use any of these methods. One is mathematical and another one is experimental method. And coming to the mathematical method, so there is an equation that given. So KT is given by 1 plus 2a by b. So where a is the 2a is the total length of crack. So for example, in the earlier case, you can take a circle. So the diameter of the circle is considered as a 2a, and the height of the circle is considered as a 2b. So where a is half the length of circle or crack, and b is the height of the crack, half the height of the crack. So from that we can get the value of KT. So for example, so if it is in crack